Dear students, now I'm going to solve one problem from quantum mechanics. The work function for metallic chromium is 4.4 electron volt. Calculate the kinetic energy of electrons emitted from a chromium surface when it is radiated with a radiation of wavelength 200 nanometer. We know if we radiate of certain frequency of radiation on metals, that radiation can emit the electron from that metal. Such phenomenon is called photoelectric effect. We know the light radiation consists of small energy packets. We call it as photon or quanta. This photon can eject an electron from the surface of the metal. So the radiation energy will be utilized to overcome the binding energy of this electron. So such minimum energy required to eject an electron from an atom in a metallic surface is called the threshold energy or work function. So in this particular question, it is asked to calculate the kinetic energy of this ejected electron from the metallic surface. So if we use a radiation of certain frequency which is exceeding the threshold frequency, the excess energy will be utilized as the kinetic energy of the ejected electrons. So in this particular question, they used a radiation of wavelength 200 nanometer. So we have an equation for the energy of the radiation will be utilized to overcome the threshold energy that we call as work function. So let it be represented by phi. Then the excess energy will be utilized as the kinetic energy of the electron, ejected electron. So this can also be written as h nu 0. Nu 0 means the threshold frequency of this particular metal, and the kinetic energy can be represented as half mv square. Okay, so in this particular question we need to calculate the kinetic energy. So we can rearrange the equation as h nu minus phi. Phi means the work function, and we have given that in this question, that is the work function is 4.40 electron volt. We need to convert into joules. For that we need to multiply with the charge of the electron. So 4.4 into 1.6 equal to 7.04 into 10 raised to minus 19 joules. So that is the work function. That is the minimum energy required to eject an electron from this metal by a photon. Okay, so and the wavelength of radiation used is equal to 200 nanometer. From that we can calculate the frequency of the radiation. So nu is equal to c by lambda, where c is the velocity of light. So that is 3 into 10 raised to 8 meter per second, and the wavelength is 200 nanometer, so that can be converted into meters, 10 raised to minus 9 meters. So if we calculate, 3 by 2 means 1.5 into 10 raised to 15. Okay, 10 raised to 15 means 8 plus 7, 15 second inverse. Okay, this is the frequency of the radiation, and we need to use the value of Planck's constant x. H is 6.626 into 10 raised to minus 34 joule second. Okay, now we can substitute these values here. 6.626 into 10 raised to minus 34 joule second into nu, that is the frequency of radiation is 1.5 into 10 raised to 15. Okay, so then we need to subtract the work threshold energy from this radiation energy, 7.04 into 10 raised to minus 19. Okay, then we need to multiply 6.626 into 1.5 equal to 9.939 into 10 raised to 34 minus 15. So 9 minus 19 minus 7.04 into 10 raised to minus 19. So 9.39 and 39 minus 7.04 is equal to 2.899 into 10 raised to minus 19 joules. So if we want to convert into electron volt, we need to divide by the 1.6 into 10 raised to minus 19. So 1.6 1.891 electron volt. So this is the kinetic energy of the ejected electron from this chromium metal surface if we irradiate with a radiation of wavelength 200 nanometer. Okay, now we will consider another problem. So let's consider another problem. Here the question is, the work function for metallic sodium is 1.82 electron volt. Find the threshold frequency. In the previous question itself we have seen the equation for work function is phi is equal to h nu 0, where nu 0 is the threshold frequency. So in this equation the work function is given, that is phi is equal to 1.82 electron volt, that we can convert into joules. 1.82 into 1.6 is equal to 2.912 into 10 raised to minus 19 joules. So we need to find out the threshold frequency nu 0. Nu 0 can be obtained by dividing this work function with Planck's constant. So 2.912 into 10 raised to minus 19 divided by 6.626 into 10 raised to minus 34 joule second. So we'll be getting 0.439 into 10 raised to 15 second inverse. So if we want to convert into electron volt, so this is the frequency. So this is the frequency of the threshold frequency. This is the threshold frequency required to eject an electron from the sodium metal. Okay, so like this we can easily calculate the threshold frequency and the threshold energy. If the threshold energy is given and the radiational wavelength is given, you can find out the kinetic energy of the ejected electron. Okay, thank you.